All right, well, thank you for that, Chris. Well, until 3 weeks ago, I knew nothing about this organization. All right? Well, maybe 6 weeks ago, when Chris and Phil Sexton reached out to me. So the last 6 weeks has been an amazing education for me. And when Chris read the article, he contacted me, asked me about it, and I said, yeah, weather is changing, probably faster than the industry is changing. This is a very slow industry to change. I've been in it for 40 years, and some of our clients are still doing the same thing they were doing 40 years ago. Even though technology has changed, equipment has changed, the materials we use have changed. There's one community in New Jersey that still insists on starting with a layer of sand on the road because the residents of that town don't want to see any salt. There's another one that puts so much salt on the road that the roads are always white or black, and that town the governor lives in. So the governor doesn't want to see any snow on the roads. So technology and data is very important to this industry. And what I tried to stress in the article, is that we really need to warm up to that. Obviously, you're here because you have already, but you have to be committed to looking at data, looking at new technologies, etc. Now, like I said, it's only been 6 weeks that I've known about this organization, but I like to say this is not the miracle on ice, but miracle with ice, because I think the goals and the mission of this organization are amazing. This is my first time. I'm not touching anything. And that's the end. So any questions?
What if we blinked?
Okay.
Wow, you're good.
So I was really impressed with the organization. When Phil said, take a look at a couple pieces of literature, I tend to obsess over things, and I started thinking, why aren't they doing this? Why aren't they doing this? Why don't they add this technology? So I may be visiting more often in the next few years. It's my first time at Lake Placid, and I was just in Italy for 3 weeks, and that ride from the Northway here, outdid almost any drive I was on the last 3 weeks in Italy. So, never thought I'd say congrats to New York. So, anyway, just the fact that you've even started this program and you have such a good attendance, and there's research being done, there's cooperation amongst contractors, municipalities, meteorologists in the industry, even businesses now getting involved. Everyone needs to be on the same page. We know that. But in order for that to be successful, it takes a long-term commitment. People tend to start these projects. Okay, all right. I guess I got a heavy thumb. I might have to engage someone, and this is it in reverse. All right. I apologize. All right. So it does take a commitment. I've seen a couple of these initiatives started in New Jersey. I'll give you a quick example. And by the way, if any of you want to know anything about my background, I had a couple slides in about that, but I just took them out. You can ask me later privately. I've been in the business for 40 years, mainly in the snow and ice industry. When I say in the business, on the meteorology side, not behind the steering wheel or in a truck. The program in New Jersey that was started was in a sensitive area of northwest Jersey, and what happened was that initially the highest level starts this program. But in order for the program to be successful, everyone has to be committed in that chain, down to the driver of the truck. And what was happening is, it was a PR campaign. It was a PR campaign that ended up spending a lot of money, but was very unsuccessful. The campaigns and programs you have here seem to be having some success, which excited me. Otherwise, I probably would have said no to Chris. But it takes collaboration and commitment, and it takes understanding not just today's weather conditions, but what's changed from last year. How is that going to affect how we use our equipment, or how we use our resources, our brine solutions, etc. Okay, I'm sorry, I'm going to do this. So I like to start with data, but I'm not going to bore you with data because there's a lot of it. A lot of this was brand new to me. I didn't have a prepared presentation for this. So this was developed for this group. So what I did was I took some data from the article that Chris talked about, and this is one of the tables, one of the charts we put together. And then I reviewed a set of other data that's more specific to the Champlain Valley and upstate New York. This particular graph, real quickly, all I want you to see here, and you said the pointer's not working, right? Okay. So I don't think this is going to show up on everybody's screen. But the trend in the northeastern part of the U.S. over the last 30 years is that the shorter period climate averages are increasing or flat. So we'll look at Montreal, for instance, 30-year average in yellow, but the new 30-year average, we'll explain this a couple slides down further. This is the 30-year average between 1990 and 2019. The orange is the 30-year average. This is, where's yellow here? The 1981 to 2010 average, and then 1990 through 2019 is in orange. Most of these indicate, this orientation indicates that the 5-year average snowfalls more than the 10-year, more than the 15, more than the 20, more than the 25. So there appears to be a trend in the northeastern part of the country and in a couple of other areas of the country that snowfall has been increasing. Now, when you hear the term climate change, it's usually associated with the word global warming. Now, I was hoping that you would all be eating still so I wouldn't get anything thrown at me or any argument. I'm not here to discuss cause. I'm just here to talk to you about statistics. But obviously global warming has become this huge argument in the country. And when people hear climate change or global warming, politics become involved. So we're going to skip past the cause, and we're going to just agree today that, okay, we're just going to agree that we're just going to look at data, and we're going to review data that exists and that most of the scientific community agrees is accurate. This is not a chart that I prepared. This is a chart that comes from NOAA, and it shows a consistent trend of warming temperatures. I will zoom this down to Burlington, Vermont, and Albany in a little bit, but I want you to see the big picture first. This is what you hear about on TV. Global warming, climate change. Global warming, climate change. I believe it, I don't believe it, etc. But the trend for the last, on this chart, the trend from 1950 through 2010 is above the average temperature by about 1 degree. Okay, I guess I got to point this way. If we extend this to 2020, we see that since 1910, the temperature departures have been warming, okay? Meaning that if we take the average temperature across the globe, every year over this period, there's been a warming trend. Now, you think that because there's a warming trend, there would be more snow or less snow? Anybody have any suggestions? Less, more. Okay, pretty much. I think you said the same thing, less and more. All right, so, and both are true, but not for the same geographic area. So what we're seeing is that with this warming trend, there is more snow in certain areas of the country, and there's less snow in other areas of the country. And then there's a transition zone in the country that's developing that is producing more mixed events. They just can't make up their mind. Baltimore, Tennessee Valley, parts of the Midwest. So again, no political agenda. I just want you to look at the data. At the end, we're going to try to figure out what that data means. And I may raise more questions than I give answers, but I'm willing to discuss them with you. Not blue, just science. Okay, the data that we're going to be looking at is from Albany. The reason I chose Albany and Burlington, Vermont, and occasionally Boston, is because it was the best source of data in the limited number of time that I had to prepare this report. And we'll try to provide some insight into trends, okay? So the key word here is trends, not what happened last year, not what happened, thank you. Still going. I think my thumb is just so warm. Is that this where I?
Yeah.
Climate change, right? Okay. All right. Let's look at a couple definitions here. And I think most of you have heard this enough, but the distinction between weather and climate. Last year, President Trump had a famous quote. He's got a lot of them. But he had a famous weather quote where he said something like, it was the coldest period of the winter. And he said, well, what do you think about global warming now? Okay, something to that effect. I'm sure he said it much better than I just did. So a particular cold period, a huge snowstorm, a record-breaking snowstorm, a flood, weather, not climate. Okay? Climate is made up of all of those weather events over a period of time. The typical climate average that NOAA uses and that most statistics that you see or you pull up online are based on a 30-year climate average. So the Weather Service uses a rolling 30-year climate average. Every 10 years, every decade, it updates that 30-year average. So does anybody know what the average snowfall is in your location? Oh, that's bad. We got to educate these guys. Phil, how much snow do you get? 60? Very good. You're looking at Albany's data, right? All right. Very good. So, Albany's data, Albany has about a 60-inch average snowfall per year. That average that you pull offline or get in any table is from a period that 1989 through 2010, correct? All right. It updates every 10 years, and it's a 30-year average. So the data you're looking at is 10 years old, basically. It doesn't account for anything that's happened in the last 10 years. Okay. I was going to talk a little more about Italy, but all right.
Use the space bar instead.
What was that?
Use the space bar to be safe.
Space bar? Okay, yes. All right. Thank you. All right. So just a couple of quick examples. So down in Louisiana, we have a client in the Baton Rouge area. Coastal communities dealing with rising seawater levels and saltwater intrusion into rivers and groundwater wells is a direct result of climate change. Seawater is rising, and that seawater infiltration and intrusion into the soil is affecting those wells near the seawater. There's a point here. I know you're wondering, why is he talking about Baton Rouge? Okay. I was recently in Italy, I told you. 1.5 inch hailstones. By the way, that's not a real ruler that day. I put that on the photo. Okay, but the hailstones were 1.5 inches and entirely covered the ground. I know you saw this picture several times already. Entirely covered the ground in the main piazza in Florence. I don't know if any of you have ever been there to that piazza, but 2 inches of hail fell. Very unusual phenomenon. This is the third significant accumulating hailstorm that they've had this summer. Climate change. Now, here's the difficult question. Are rising levels of salt in the lakes and rivers of upstate New York and Champlain Valley a result of climate change? I don't know. And okay, I'm very analytical. So when my wife asks me a question, I always say, I don't know. I got to think about it. I got to figure out. I got to do the analysis first. And it takes me 3 days, and then I'll give her an answer. So I don't know the answer to this. But the obvious one is no. How can it be? It's a result of salt applications, or the wrong types of salt, or bad equipment. So is it socioeconomic pressures? Is it the municipalities like in New Jersey wanting to make sure that there's absolutely not a snowflake on the ground? Is it just bad maintenance practices? Is it bad weather data? Now I start thinking, okay, maybe there is a relationship. Maybe there is a relationship between changing climate and the salt in the lakes and rivers. It's probably all of the above. But I wouldn't be too quick to rush to judgment there. Usually the weather gets blamed for everything anyway. And you can save the weather jokes until I'm done. And I didn't realize there was another meteorologist there, so he can take half of them as well. So climate averages, I talked about this. NOAA updates their 30-year climate average every decade. The following map is a comparison between the existing data that you're aware of and a quickly recalculated 30-year period. It's actually 29 years. So don't look too closely at the numbers, but it's 29 years, but I say it's 30 because I figured you'd only see the slide for a few seconds. All right, so on this, notice the changes. So the percent change is in the total average annual snowfall. Where do you notice the increases in green? In the Northeast and parts of the Midwest, the Northern Rockies. The significant decreases are Nashville, who's lost half of their average snowfall almost in the last 30 years. The Southeast, Denver, snowfall's down. Now, climate change problems here, very light snowpack, that's causing deficits in water supplies. And that's been ongoing for the last 5-6 years. In the Northeast, good billing revenue for snowplowing contractors because snowfall's been above normal. Boston, 11.3% has been, that's the change. They're getting 10% more snow in this 30-year period than they got in the previous 30-year period. So if you're still using old climate data and you're creating a billing model in Boston, you're estimating less snow than falls. So if you have a typical winter and you're billing seasonal contracts, you're going to get burned because you really get 10% more consistently in the last 10 years. Oh, I was supposed to do that before I talked about those regions. Okay. It's always easier on my laptop. All right. Let's look at some of the data. And this is now zoomed into this area. All right, so the rest of the presentation will talk about data that I collected quickly and prepared some couple of tables. Burlington shows a slight increase in snowfall total, about 3-4% increase in the new climate average. And that average will be determined after this winter. So next year, NOAA will release these new numbers, and there'll be a new climate average from 1991 through 2020. 1991 through 2020, yes. Albany's fairly flat at about 60 inches. So, but Buffalo's up in the state of New York. New York City's up, as you just saw on the previous map. Most of New York State, all of New England is up. Albany, unless I made a mistake on some of the data, I have someone here that can check it for me, but unless I made a mistake, it looks like it's flat over the 30-year period. A couple of interesting things to look at here. The all-time record snowfall in Burlington occurred during the last 10 years. 2010, 11, I think it was, or 2010, the actual storm was. 128 inches for the year. But what's interesting about the last 10 years here is that, okay. We also had the least amount of snow to occur in the last 30 years. So both the least and greatest amount of snow fell within about 4 years of each other, 4 or 5 years of each other in Burlington. And we'll take a look at this in a little bit because another variable that I looked at is the variability of snowfall changing year to year. So should we expect more extremes? 1 year, 2 inches, 1 year, 50 inches. How do we plan for that as an organization? Okay, this is just a comparison again between the long-term average trend. Global temperatures going up, but Burlington and most of New England, snowfall's going up as temperatures go up. We'll talk about the physics a little bit later too, but it really won't be a physics class. Okay. All right. Average number of snowfall days. Now remember the previous slide. Average snowfall in Burlington is going up. Average snowfall days. The trend 30 years ago, 54.5 days. But the trend now is pointing to 50 by 2020. So 4 less days of snow, but more snow. I think it's exciting. You guys look bored. See, that's the kind of stuff that excites me and gets me going on to the next graph. Okay. And I was told not heavy on the technical graphs, okay? But I have to show you this because this is, again, what excites me. Albany, 30-year average, 34.4 days 30 years ago. Now trending towards 30 in the next year or two. So also lost some snow days. So we're losing snow days, it's warming up, and it's snowing more. I mean, that's a great business model. You build all in one day. In another 20 years, one storm, boom, you're out, make all your money in one season. Less snow, less salt also. And I'll get to that later. Because if there's fewer storms, you're going to put down less salt. And it's going to help your program. And climate change is affecting the program. Okay, but I don't want to get ahead of myself. Okay, so snowfall averages will change depending on the time period analyzed. And what I mean by that is, if we look at a 30-year average and then we look at a 5-year average, they're going to be different. They're always different. And that's something you need to understand. I always encourage my clients to look at both. Because the climate is changing, it's important to see what the shorter-term climate changes are. And pay attention to that. Okay, your average snowfall is 60 inches in Albany, but the last 5 years, we've gotten 70 inches every year. So I do believe that things are going to average out, but when the trend is upward, my focus would be, I'm going to plan on more snow rather than the 60 inches. So I like to look at both averages and compare them. Okay, just for comparison purposes. Burlington, Vermont, 5-year average 82 inches, 30-year average 86 inches. The 30-year average is actually more than the 5-year average, because the last 4 years, their snow has been on the lighter side, and they had that one very light year of 30-some inches. Just an important number down here, and not to get into statistics too much, but the standard deviation, okay, measures kind of, it's just a measure of the variability of a number. So if your average snowfall is 60 inches, should I expect 70% of the time that my snow is going to be between 50 and 80 inches? Or 120 inches? Okay? Where is that range? And that's what this number tells you. So the higher this number, the more that spread is, and the more unpredictability for that season there is. So in the current climate period that the Weather Service has out now, the variability is 19 inches. So your spread is 19 inches. In the current period, that's grown to 27 inches. The reason for that is those two extremes that we just saw within that same period. So the spread, someone plowing snow in Burlington can expect anywhere from 127 inches to 80 inches, 77 inches, something like that. Huge spread. I thought these were interesting. This is measuring the first and last freeze in Albany and Burlington over the 30-year period. And this, to me, this was very significant. And again, we have a meteorologist here from Albany, so I'm sure he's going to go and check my data. But 1989, the average first freeze day in Albany was on or about the 30th of September or October 1st. In 2018, it was an average of somewhere around the 17th, okay? The trend line, though, the trend is pointing up above that, more like October 20th. So that's 3 weeks of additional growing season at the beginning of the season, and it's 3 weeks where ground temperatures are warmer, where less salt can be used because there'll be more melting. So again, important data to know that for this organization. or if you have a farm like Phil does, and you're worried about, when your first freeze is going to be. Burlington, same trend. The difference is Burlington also shows a later date an earlier date in spring. So not only is Burlington gaining a growing season in the fall, but they're adding another week on in the spring as well. Again, all of this points towards climate change and warming temperatures. It's still snowing, so you all have your jobs. It's still snowing, and we're still going to sell salt, but for some reason it's snowing more, even though most of these trends show a condensed snow period. All right, so before I get into this, so it's snowing more, but it's snowing less at the beginning of the season, less at the end of the season, and more in the middle. And somehow I think we missed that slide. Because this shouldn't be here. That slide got mixed. That slide is back a little bit. And I don't want to go back. Is it really 1 o'clock? We didn't start at noon. When did we start?
We started about 12:30, about 10.
Okay. So why is more snow falling even though temperatures are rising? Can it be too cold for snow? Theoretically, no. I mean, it can snow at any temperature, but the colder air does limit the amount of moisture in the cloud. So a colder atmosphere typically will produce less snow than a warmer one. Now, you understand when I say warmer, it can't be above freezing, all right? It's still below freezing, but it's relatively warmer. So it's a ground temperature of 15 or 5 below zero really doesn't support a lot of snowfall. Cloud temperatures have optimum conditions for snow growth and for snow development. And they are becoming more optimized with warmer climate, basically. So warmer air holds more moisture. And when you have warmer air at temperatures that support snowfall, you have bigger snowstorms. So in the core of the winter, when it's cold enough for snow, we're getting bigger snowstorms in this part of New York State and in New England. In the fringe periods, where temperatures are marginal, we're not seeing as much snow. We're losing snow days, and our first day and last day of freeze have shrunken. So our snow season's smaller with fewer days, but more snow. All right, so we'll summarize again. I kind of just did that. Average temperatures are rising slowly in our area. Snowfall season is shrinking, but core months receive more snow and fringe months receive less. The core months are December, January, and February. March, forward, less snow, and fall snows have become less as well. Okay, a couple of takeaways, and the takeaways are, again, my point of view. I'm not in your specific industry, and a lot of the salt reduction initiatives for me were new to learn, but from what I understand, salt applications will start, and these are positive, okay? There's two of these screens. The first one is a positive takeaway, because I'm not sure of the answer, and I'm open to discussion. The next screen, some of these will be duplicated because they can work against us as well. So salt applications theoretically will start later in the fall and end earlier in the spring if this trend continues next decade. And that will help reduce salt applications. Warmer transition months may facilitate melting with less salt applications needed. Core months of winter will produce heavier snowfall totals with fewer events. Increased mechanical removal of the snow may reduce the need for salt. So if we have bigger storms and better equipment where we can scrape more, our applications will be reduced. Best practices for reducing snow road salt work best when weather conditions are static, okay? We all understand what best practices are, but they work best if we know what the weather conditions are. If weather conditions are changing, do those practices apply as well? Or do they need to be modified? I don't know the answer to that, but Phil might ingest some information into that. Changing weather patterns need to be considered when developing sustainable salt application strategies. Introduce new technologies like thermal mapping. Has there been any thermal mapping of any significant or major roads in the area to help with salt reduction? Okay, all right. So it's just the idea is if we know, for instance, that the roadbed temperature in a certain area of a road is consistently warmer and will aid in melting the snow faster, why apply salt? It's as simple as that. It's more involved, but that's why I put that thought there. Okay, warmer transition months may lead to more mixed events. Okay, this is where I need 5 years of study in order to really determine what will happen. And those mixed events could result in an increase in de-icing events because they may be sleet, they may be freezing rain, not snow, where we can't remove them mechanically in the transitional months. An increase in weather volatility will likely produce more extreme events and challenges for planning. Best practices for reducing road salt will become more challenging when weather changes more frequently. And changing weather patterns need to be considered when developing sustainable salt application strategies. Okay, I'll end with our winter forecast. Little plug for Jim Sullivan, who put this together a few days ago. And look at what he says. Snowier than normal through the central and southern New York tier and into most of New England. So the trends, at least the way we view the long-range predictors, are that we will see a snowy winter, and the changes that we've seen, that we've talked about, will be consistent with this weather, with this season coming up. And I have a few minutes for questions. You were a great crowd. I thought there'd be a little more heckling. It's a tough subject to talk about global warming or climate change.
Well, thank you, Frank. We have a couple minutes for questions if people had any.
Yeah, I have a couple minutes for questions, and I will be here all day. I'm more than happy to talk to you. You can email me. I guess there is one more slide. But you'll get this presentation, I believe?
Yeah. We'll have all presentations up, posted on our website with links to the other organizers as well.
Question?
So Frank, how do you just pointed to that map, you said this winter looks like more than normal snow. How do they come up with that? They just look at trends over the past 30 years and put it into a computer, and that computer says, well, based upon what's happened over the last 30 years, we should have. My question was, you showed that map before. You said this winter we're going to have more than normal snow. And my question is, how do they predict that? Do they look at trends over the past 30 years? Do they use a Ouija board? I mean, seriously.
Well, we do have a crystal ball, but not a Ouija board, okay? No, I know you are. And it's a tough question. I used to, for years, before the science of long-range forecasting improved, I was not a believer at all. But, and I used to, the Farmer's Almanac comes out with forecasts every year, and I would tell a crowd like this, take a date in February, put it down on a piece of paper, give me that date, I would pick out that number out of a hat, and I'd say, I can tell you that there's a 70% chance that it's going to snow on that day that you just picked in February, plus or minus 2 days. Because it snows every 4 days in February. All right? So, and that's what the Farmer's Almanac bases a lot of their forecast on. It used to. It was more just climate, just like you said. What's the trend of the last 30 years? This is based on what's happening globally on Earth. And there are statistical relationships that are called teleconnections. So if someone on the other end pulls the rug real hard, and 60% of the time you fall off the chair, I know that that's a predictor for me. If he does it, I'm going to look at you and I'm going to say, no, it didn't work this time. It must have been one of the 40. So there's these predictors that are long, that are connected to, for instance, the ocean temperature in the Atlantic. They're connected to high pressure areas in. Pardon?
I think you lost him.
Oh, no. At which part? The rug? Okay, okay. But anyway, so they're based on, and can you explain it any better? Okay.
I'm not going to try.
Okay.
Yeah, you don't want to get it.
So it's not as easy as just looking at data, but there are a lot of these predictors, and they're consistently, none of them are 100% accurate. Most of them are only 55% accurate. But if you look at enough of them and they point in one direction, you start favoring that direction. That's the best I can do.
So global warming
Uh-oh.
may not be a real issue.
No, global warming is,
Not-
but who caused the global warming? That's the political issue.
I'm not going there.
Yeah, but.
Time for one more question? Okay. Well, with that, one quick question.
A follow-up, Frank. To
Yeah.
Your predictors and your teleconnections, what year are you using as an analog year to mostly?
Well, and that's a completely different method. We do look at analog years, but the teleconnections are based on current data. Right, but the analog years, I'm not sure what Jim looked at. I'm not sure what analog years he looked at, but analog years are just similar years that where weather patterns that are occurring now will find similar years in the past and see what happened. A good question, but I don't know the answer.
Okay.
All right,
Frank, well, I appreciate it.
thank you. Thanks, everybody.